Autoboxing. Autoboxing. So can you tell what is the purpose of or what is the meaning of autoboxing? Autoboxing. What is autoboxing? Here just observe. I have one primitive value is there. Primitive value. Keeping primitive value inside a box. Keeping primitive value inside a box is called autoboxing. Again, keeping primitive inside a box and project that as an object is nothing but autoboxing. Sir, remove the box. Remove the box. Then we will get what? Primitive auto unboxing. Keeping primitive inside a box is called autoboxing. Remove the box and find out primitive is nothing but auto unboxing. Literally we are doing the same, but we can't tell this type of words. Okay, this in the entire room, if any person can ask what is autoboxing, auto unboxing, sir, keeping primitive value inside a box is called autoboxing. Remove that box is nothing but auto unboxing. Don't use this type of words, but literally it is the same, but don't use. What is autoboxing? Simple. Automatic conversion of auto means automatic conversion of primitive to wrapper object. I have primitive value is there, I want to convert primitive to wrapper object. Automatic conversion of primitive to wrapper object by compiler. Who is the responsible for this conversion? Compiler. Automatic conversion of primitive to wrapper object by compiler is called autoboxing. Is it clear for all of you? Okay, this is. So what is autoboxing? Here say this one. Here I am taking. Here just observe. Integer I is equal to 10. Sir, here just observe. Integer I, it is always expecting what? Wrapper object, because I is reference variable, it's always expecting object, integer object, but instead of that I am taking 10. Is it valid or not? Valid, no problem at all, because automatic conversion from primitive to wrapper object will be performed automatically. Are you getting? Integer I is equal to 10 itself is valid or not? Yes, valid. Okay, compiler converts into integer automatically. Compiler converts into integer automatically by autoboxing. Are you able to understand, right? Compiler converts into integer automatically by autoboxing is nothing but what? Okay, this. So can I spell out what is autoboxing? Automatic conversion from primitive to wrapper object by compiler is nothing but what? Autoboxing, right? Now that analogy is very clear for you. Add autoboxing. Automatic conversion of primitive to wrapper object. Automatic conversion of primitive to wrapper object. Automatic conversion of primitive to wrapper object. Wrapper object by compiler. Automatic conversion of primitive to wrapper object by compiler. By compiler is called autoboxing. By compiler is called autoboxing. Autoboxing. Example. Integer I is equal to 10. Integer I is equal to 10. That compiler converts into integer. Compiler converts into integer automatically. Compiler converts into integer automatically by autoboxing. Compiler converts into integer automatically by autoboxing. So I hope you people can aware. Are you getting the point? So do you know how the compiler can perform? So you may have the big doubt. Here simple. Listen this one. After compilation, this line will become. After compilation, this line will become, integer I is equal to, sir, how to convert primitive to wrapper object? Which method is required? Primitive to wrapper object, value of, primitive to wrapper object, value of. Now at the time of compilation, this line will be replaced as integer dot value of 10. Okay, who is the responsible to place this line? Compiler is the responsible. That's why we can use the word compiler is responsible to perform autoboxing, right? Are you able to understand? So after compilation, this line will become is nothing but like this. That's why internally autoboxing concept is implemented by using which method? Value of method, right? Okay, at this point, after compilation, the above line will become, after compilation, the above line will become, the above line will become, yeah, the integer I is equal to, the above line will become integer I is equal to integer dot value of 10. Integer I is equal to integer dot value of 10. After compilation, the above line will become integer I is equal to integer dot value of 10. That is internally, autoboxing concept is implemented. Internally autoboxing concept is implemented by using value of methods. Are you getting that? Okay, this is. So what is autoboxing? How the compiler can perform? Internally how it is implemented by using value of methods, right? Any doubt on any explanation is required? Okay, now here just observe the same thing in reverse. Just observe, sir. I'm taking, I have integer I is equal to new integer of 10. Integer I is equal to new integer of 10. Sir, I have integer object is there. I want int I is equal to, sir, int I always expecting, int I always expecting what? Primitive. But instead of primitive, let me provide wrapper object, right? Instead of primitive only expecting, but I'm providing a wrapper object. Is it valid or not? Yes, is nothing more. Now here internally, here compiler converts integer to, compiler converts integer to int. Automatically by auto unboxing. Are you getting that? Okay, this is. So how this concept internally implemented? Do you know? After compilation, this line will become. Do you know? Wrapper object to primitive. Which method? Wrapper object to primitive xxx value. That's why I dot int value. After compilation, the above line will become is nothing but line. Who is the responsible to place this line? Compiler. That's why compiler is responsible to perform auto unboxing, right? Internally, auto unboxing concept is implemented by using which method? Xxx value method. Are you able to understand that? Okay, add. Keep suffering. Auto unboxing. Under that add. Automatic conversion of wrapper object to primitive. Primitive by compiler. Automatic conversion of wrapper object to primitive by compiler. by compiler is called auto unboxing, is called auto unboxing, is called auto unboxing, unboxing. Okay, this is. Now take this example, only these two lines. Integer I is equal to new integer of 10. Integer I is equal to new integer of 10. Integer I is equal to new integer of 10. Next, int I is equal to capital I. Int I is equal to capital I. Capital I. Get the point. Within bracket, just only up to this. Compiler converts integer to int automatically. Compiler converts integer to int automatically by compiler converts integer to int automatically by auto unboxing. Compiler converts integer to int automatically by auto unboxing. Okay, completed, right? Next, after compilation, the above line will become, after compilation the above line will become yeah, int I is equal to capital I dot int value. Int I is equal to capital I dot int value. Int I is equal to capital I dot int value. Are you getting? That is internally auto unboxing concept is implemented. Internally auto unboxing concept is implemented by using x value, by using xxx value methods. Internally auto unboxing concept is implemented by using xxx value methods. Okay, that's all. Are you able to understand, right? What is autoboxing, what is auto unboxing, right? Now just observe the point well. Sir, I have primitive value is there. Sir, this is my primitive value. Sir, this is the primitive value. I want to convert the primitive value to wrapper object. Primitive value to wrapper object. Do you know? This conversion is called what? Autoboxing. This conversion is called autoboxing. Internally, which method it is going to use? Internally, which method will use? Value of method. Correct or not? Okay, this is. Now same. Sir, this conversion is called what? Wrapper object to primitive. Auto unboxing, and internally which method we are going to use? X value methods. Are you getting? Take this diagram. Primitive value to wrapper object to primitive. So automatic conversion of primitive to wrapper object, autoboxing, wrapper object to primitive, auto unboxing, right? So make sure completed, I hope. Automatic conversion of primitive to wrapper object to primitive, autoboxing, auto unboxing. So value of xxx value. Okay, so just let me go for some examples based on this autoboxing and auto unboxing. Yes, a very easy examples I'm taking, so just aware. Sir, I'm taking class test. Very important, observe class test. Sir, static integer I. Static integer I am taking. I is equal to 10 I am taking. Static integer I is equal to 10. Public static void main method. Public static void main string array args. Int I is equal to capital I. Int I is equal to capital I. Next I am calling m1 method by passing I as the value. I am calling m1 by passing I. Public static void m1. Public static void m1 of, here I am taking integer, okay, this is some capital I. Integer I am taking. I or integer some k. Int I or int m is equal to this k I am taking. Int m is equal to k. System.out.println of m, like I am taking. Are you getting? Sir, static integer I is equal to 10. Int small I is equal to capital I, m1 of I. This m1 is expecting integer type. Now k I am trying to assign to the primitive, now SOP of m. Almost between wrapper object and primitive, almost all possible dancings. Are you getting right? So can you tell, is it valid or not? Yes, perfectly valid. Okay, so in the 1.5 version, perfectly valid, because in the place of wrapper object you can provide primitive. In the place of primitive we can provide wrapper object. If any conversion is required, my compiler is going to take care. Now static integer I is equal to 10. Can you tell here which conversion will be performed? Sir, primitive to object. What is this concept? Autoboxing. Okay. Int I is equal to capital I. Int I is equal to capital I. Okay. What is this capital I? Integer. So integer wrapper object to primitive. What is this concept? Autounboxing. Now m1 of I is what type? Int type. This int value I am trying to send to integer. Sir, into to integer is nothing more. What is this conversion? Is Autoboxing 1 second. Next, into to integer. Integer to int. What is this conversion? Is nothing but Autounboxing. No problem at all. Happily the code compiles and runs fine. If I run this code, what the answer by default we are going to get is 10 by default. Are you getting the point, right? But the same example, if you compile in the 1.4 version, is it valid or invalid? Compile time error we are going to get 4 errors you will get it every year. Incompatible types, found int required integer, incompatible types, found integer required int. M1 of integer cannot be applied to int, is nothing man. Incompatible types, found integer required int. In the 1.4 version 4 compile time errors you are going to get, but in the 1.5 version is nothing but this one is the valid. Are you getting? Let me compile and run in both versions so that you can identify the difference, right? Here see. So just I am taking same example I am taking here just. So let me 1 minute. Let me compile and let me. Okay, here just have a look once. Class test static integer I is equal to 10. Public static void main int I is equal to capital I, m1 of I. Integer I is equal to k. Int m is equal to capital K, SOP of m. Like this I am taking. Correct? Same code or not? So I am using which version of Java? 1.6 version. 1.6 version or 1.7, no problem. Valid or not? Java C test.java. Perfectly valid. Next, Java test. For the answer, 10 by default is the answer. Because we are using which version? 1.6 version, right? Sir, compiler, can you please compile this code according to 1.4 version? According to 1.4 version, can you please compile? like Java C. How to spell out? Compile according to 1.4 hyphen source 1.4. Sir, we can compile Java program according to a particular version by using hyphen source followed by test.java. Is it going to compile or not? Yes, boss. Is nothing but like compile time error. How many errors we are getting? 4 errors. Have you observed? If you consider first error, incompatible types found in the required integer. Second compile time error, incompatible types found integer required int. Third compile time error, m1 of integer in test cannot be applied to int. Fourth compile time error, incompatible types found integer required is nothing but int. Are you getting? So this program is valid in 1.5 version but invalid in which version? 1.4 version. Okay, take this example first. Take this one clearly. So and which conversion is happening, that one is also there. Take clearly. Static integer I is equal to 10. So in the place of object we are providing primitive Autoboxing. Public static void main int I is equal to capital I. Auto unboxing m1 of I. So nothing but like Autoboxing into m is equal to k. Like take clearly. SOP of m. Completed, right? This is what you people should aware. Share the comments clearly. Autoboxing, auto unboxing, like what output by default we are going to get itself is the 10. Clear, I hope. Okay, now just beside this you have to add the theory. Just beside this one here, it is valid in which version? 1.5 version. It is valid in 1.5 version but invalid in which version? 1.4 version. But invalid in 1.4 version. 1.44 version. Valid in 1.5, invalid in 1.4 version. Completed, right? Okay, this is next point. Take a bit special care about this word here. So can I use the word just because of Autoboxing, auto unboxing? From 1.5 version onwards, primitives and wrapper objects interchangeably we can use. Correct or not? In the place of primitive you can use wrapper object. In the place of wrapper object we can use primitive interchangeably. So we can use because of Autoboxing and auto unboxing, right? Take a note. Just because of Autoboxing and auto unboxing. Just because of Autoboxing and auto unboxing. Just because of Autoboxing and auto unboxing. We can use primitives and wrapper objects. We can use primitives and wrapper objects. Interchangeably. Interchangeable, something like interchangeably. We can use primitives and wrapper objects interchangeably from which version onwards? Interchangeably from 1.5 version onwards. interchangeably from 1.5 version onwards. From 1.5 version onwards. Okay, that's all. So Autoboxing, auto unboxing example 1 clear for all of you, right? Okay, now let me go for example 2. Here legend, this example is also a bit very important. Some conclusion is there. Make sure you should have clear idea. Sir, I am taking class test. Here static integer I is equal to 0. I am taking static integer I is equal to 0. Public static void main method string array args. Public static void main string array args. Static integer I is equal to 0. Main method string array args. Here my target here is int m is equal to I system.out.println of m. And m is equal to I SOP of m. Like this I am taking, right. This is my first example. Second example, a bit very important or very interesting. See, same thing only I am rewriting. Class test sir static integer I. Static integer I. I am not assigning with the 0. Okay. Public static void main method string array args. Public static void main string array args. Int m is equal to I system.out.println of m. SOP of m. Can you tell what is the answer in the first case? What is the answer in the second case? Yeah, what is the answer in the first one, second one? In the first case 0, no problem. So happily the output by default we are going to get is nothing but 0, right? No issue at all, value. Second case, what is the answer? Am I doing any syntactical mistake? No, I am not doing anywhere. I can assign wrapper object type to primitive. No problem at all. Syntactical mistake not there. Huh? JVM is always going to provide default values, man. Default values for static variables. We are not required to perform assignment explicitly. JVM will provide default value for static variables. So what is the answer we are going to get? No compile time error. Okay, make sure happily the code compiles fine. But the problem at runtime, because most of the people are going to feel static integer I. Sir, what is the default value for I? 0. Some people are going to feel 0. 0 means 0 will come like. No. Here it is object type. And what is the default value for object type? Null. What is the default value for object type? Null. Now, do you know, this line will become, after compilation, this line will become, can you spell out? Int m is equal to I dot int value. Correct or not? After compilation, this line will become like this. But make sure int m is equal to I dot int value. I is what type? Is nothing but integer. And what is the value of I? JVM is going to provide default value null. Sir, on null, we are calling int value method. Internally int value method is executing. On null, if any method is going to be executed, immediately what will happen? Null pointer exception we are going to get. That's why in the second case, null pointer exception we will get, but not 0. Are you getting? So, for the null reference, if we are trying to perform auto unboxing, then what will happen is nothing but null pointer exception we will get. Are you able to understand that? Okay, let me show this one first. Here, see, now observe this. Here int m is equal to I. Int m is equal to I SOP of m and 0. Sir, first part observe. 0 static integer I is equal to 0. Like the code compiles fine. What the answer? 0 is itself is the answer. I hope you can able to see 0 is the answer, right? Now let me remove this part. If I remove this part, what is the answer by default we are going to get? Okay, static. Here see what the answer? Yeah, null pointer exception. What answer by default we are going to get? Null pointer exception. Any explanation is required about this one? Okay, this is null pointer exception, right? On the null reference, if we are trying to perform auto unboxing, we will get what? Null pointer exception. Add example 2. Take both side by side. Take both side by side. Completed, right? Okay, now keep note on null reference, note on null reference, on null reference, if we are trying to perform auto unboxing on null reference, if we are trying to perform auto unboxing, if we are trying to perform auto unboxing, then we will get runtime exception. Then we will get runtime exception saying, what that exception? We will get runtime exception saying null pointer exception. We'll get runtime exception saying null pointer exception. Null pointer exception. Okay, that's all. Clear for all of you, right? Okay, this is. So make sure you people should aware clearly what is the difference. I mean, if I am trying to perform auto unboxing for null reference, what will happen? We know. Okay, example 3. Example 3. This example is also important. Example 3. Here see, integer x is equal to, sir, integer x is equal to 10. Legend valid, integer x is equal to 10. Integer y is equal to x. Integer y is equal to x. Now x plus plus, x plus plus, SOP of x, SOP of y, SOP of x and SOP of y. Can you tell what the answer? And even SOP of x double equal to y I am taking. What the answer? Ayo, y is equal to x. X and y both are pointing to the same. Now x value incrementing, x plus plus. Now what is the x value? What is the y value? And then x double equal to y. Okay, make sure what is the x value? 10. Oh, 11. X plus plus, semicolon already completed, incrementation already completed. X value is 11, y value is 10. 11, 10 false. Just observe. So at least up to certain level you can aware this point. Integer x is equal to 10. Sir, x pointing to 10. Integer y is equal to x. Y is equal to x. At least now you can tell correct answer. X plus plus, x plus plus, x plus plus, x value will become 11. SOP of x, what is the answer? 11. SOP of y, 11. And x double equal to y is nothing but true. Are you getting? So the answer is, so SOP of x 11, SOP of y 10, and SOP of x double equal to y is the false. Are you getting? Are you? Yes or no? Yes. My answer never be wrong. Yes or no? Yes. How many people are feeling, sir, it's not correct answer? It's not correct answer. Valid, right? Yes. So no explanation is required. Yeah, because you know, right? Is it valid or invalid? Invalid. Oh, it's not correct answer. Is this answer is the correct or not? Okay. Don't keep any doubt on this answer. Okay, I will execute and I will confirm first. Here see. Here, so class test public static void main. Here just integer x is equal to 10, integer y is equal to x, integer y is equal to x, x plus plus, and SOP of x, SOP of x, SOP of y, SOP of x double equal to y, x double equal to y. That's all. So now observe 11, 10, sir, 11, 10 false, 11, 10 false. Perfectly this answer is the correct. So you people missed a small point. Have you remember? All wrapper class objects are immutable. Have you remember? Once we create wrapper object, we can't perform any changes in that object. If any person trying to change, with that change, a new object by default will be created. A new object by default will be created, and only that particular variable will be reassigned. Have you remember this point we covered already? So all wrapper class objects are what? Immutable. Once we create wrapper class object, we can't perform any changes in that. If any person trying to change, with that change, a new object will be created. X is a reference variable for that. Is it clear, right? Okay, at this point. Take this example first. Example 3. Integer x is equal to 10. Integer y is equal to x. Integer x is equal to 10. Y is equal to x. X plus plus. X plus plus. SOP of x 11. SOP of y 10. SOP of x double equal to y, x double equal to y. For the answer we are going to have false. X double equal to y itself is the false. Clear, I hope. Not required to keep any explanation. Okay, better to take that diagram also. Okay, what is the reason why we are getting? So 11, 10 false is the answer. You have to take a note, spell out this point also. Note. All wrapper class objects are immutable. All wrapper class objects are immutable. That is once we create wrapper class object, once we create wrapper class object, we can't perform any changes in that object. We can't perform any changes in that object. We can't perform any changes in that object. If we are trying to perform any changes, if we are trying to perform any changes, with those changes, if we are trying to perform any changes with those changes, a new object will be created. With those changes, a new object will be created. That's all. So this is example 3. Okay. So now the next example, whatever I am going to take, I am sure. Okay, for the next example, I am sure your answer by default wrong. Here the beginning only I am telling. I have full confidence on you people. Check your luck now. Okay, legend. Okay. So by default your answer is the wrong for this example. Take very much special care about this one. Okay. Now see this one. Integer x is equal to new integer of 10. Integer x is equal to integer of 10. Integer y is equal to new integer of 10. For integer x is equal to integer of 10, integer y is equal to integer of 10. System dot out dot println x double equal to y. Okay. So this is my first example. Now case 1. Okay, like now I am taking case 2. Integer x is equal to new integer of 10. Integer x is equal to integer of 10. Integer y is equal to 10. Integer y is equal to 10. Have you observed autoboxing concept? Now system dot out dot println x double equal to y. SOP of x double equal to y. Third one, integer x is equal to, integer x is equal to, here 10, integer x is equal to 10, integer y is equal to 10. Integer x is equal to 10, integer y is equal to 10. System dot out dot println x double equal to y. SOP of x double equal to y is nothing but like I am taking. Now fourth option, integer x is equal to 100. Integer x is equal to 100. Integer y is equal to 100. Integer y is equal to 100. System dot out dot println x double equal to y. X double equal to y. Next, integer x is equal to 1000. Integer y is equal to 1000. System dot out dot println x double equal to y. That's all. Only 5 cases I am taking. Can you please check what the answer we are going to get? First one, false. True na? False. Second one, true or false? So observe. Second one, true or false? True or false? Third one, true. Fourth one, oh, I told at the beginning already, by default your answers are wrong. That's why. Can you tell in the first case what the answer? False. Good. Second one, false. Automatical third one, true. First two are false. Automatically next two are true. Next two are true. Next one automatically false. If anything is there, by default it is false. Any 6 one by default it is false. Can you tell where we require to change the answers among these? True, false, true, false. Where we require to change the answer? Or no change is required? Ayo. First one, false. Correct or not? Yes. Second one, true, but we are taking false. Third one, true or false? Third one, true. Fourth one, true. Fifth one, false. I wrote false only. If these answers are correct? Yes, because my answer never be wrong. Valid or not? All these answers are perfectly all are perfectly valid. Don't keep any doubt on my answers. Valid. Okay, let me show first, because otherwise you people may have the big doubt. Okay, so can you, what is the first one? Integer x is equal to new integer of 10. Okay, integer y is equal to new integer of 10, x double equal to y. Here see, what is the first one? False. The first one is the false. Correct. Okay, integer x is equal to 10, integer y is equal to 10. Integer y is equal to 10. What is the first one? False. Second one is nothing but false. Okay, so is the false. Next, third one, integer x is equal to 10, integer y is equal to 10. 10 nana. Case 3. What is the answer? True. True itself is the answer. Have you observed? True itself is the answer, right? Okay, this same. Next, 100 integer y is equal to 100. What is the answer? True is the answer. Okay. Integer x is equal to 1000. Integer y is equal to 1000. What is the answer? Good. False. The answer is false. Arey, inni correct అయినప్పుడు ఇది ఒకటి ఎందుకు కరెక్ట్ అవుదా? Why you are keeping doubt once again? Is it? What is the answer? How many people are feeling true as the answer for the last one? I will give left and right. Okay, because these many are correct. Why you are keeping the doubt in your mind? Okay, true or false? Okay, false is the answer. Okay, perfectly correct. Okay, these answers are. Sir, what is the reason? You may ask. Sir, can you please explain about the reason? What is the reason for that? Let me explain clearly, right? Here, integer x is equal to new integer of 10. Sir, whenever we are using new operator, compulsory a new object will be created on the heap. That's why, sir, x is 10, new operator y is 10, false is the answer. Okay. Second one, integer x is equal to new integer of 10. Sir, new, okay, like 10. Integer y is equal to 10. Integer y is equal to 10. Do you know? Autoboxing. Sir, concept is completely different. That's why new object by default will be created. Okay, so both concepts are different. False. Integer x is equal to 10. Sir, by autoboxing is nothing but like. Okay. By autoboxing, if an object is required to create, is it already created for autoboxing or not? It's going to check. If it is already created for autoboxing, then existing object will be reused. Are you getting? That's why what the answer by default we are going to get. I mean, y is also pointing to the same. Sir, by autoboxing, if an object is required to create, okay, we will check for autoboxing purpose, is any object already created or not? If it is already created, reuse existing object. Otherwise, if it is not there, then only a new object will be created. Sir, by autoboxing already there, y is pointing to that. So what the answer we are going to get? True, right? Okay. Next, integer x is equal to 100. Sir, by autoboxing object there, integer y is equal to 100. Integer y is equal to 100. Autoboxing only. But already for 100, object already there. So now why reuse that object? That's why true is the answer. No problem at all, because both are pointing to the same. Sir, integer x is equal to 1000 is nothing but like. So 1000 object got created. Okay, this same. Now integer y is equal to 1000 is nothing but another object got created. Now the answer is nothing but false. Are you able to get right? Are you able to get? No man, two objects are there, because false is the answer, right? False, we are getting false is the answer. Is nothing but two objects are there, correct or not? Yes, yeah, that's all. Is nothing but, that's why false itself is nothing but the answer. Okay, take this example. Take this example. At last I will explain. Take. There is a big reason is there. Take this example. So just after a few minutes you will have much clarity. Not required to worry. First document this example. What is the reason for that? I will explain. So that is hardly another 10 or 15 minutes we have to spend only on that reason. That's a big reason is there. Central point related to autoboxing, auto unboxing. Completed, right? Take all diagrams also. What is the internal reason for that? I will explain. not required to worry. First take false, false, true. Last two things are true, false. True followed by false. Completed, right? Integer x is equal to 100, integer y is equal to 100, like so p of x double equal to y, true. Integer x is equal to 1000, y is equal to 1000, so p of x double equal to y itself is the false. Clear for all of you, right? That's all, the terminology is clear for you. Okay. What is the reason? Sir, here see. Here by autoboxing, here also by autoboxing, reuse that object. But here suddenly new object got created. What is the reason for that? Here see this one. Very important. Internally, to provide support for autoboxing, a group, a buffer of wrapper objects will be created at the time of wrapper class loading. Okay, let me repeat once again. To provide support for autoboxing, a buffer of wrapper objects will be created at the time of wrapper class loading. Okay, this is wrapper class loading. So how this one is happening? Just have a look once. Sir, integer class we have. Class integer we have. In the integer class there is the static block is there. Can you tell when the static block is going to be executed? Static block at the time of class loading. Within this static block, a buffer of wrapper objects got created, right? Okay, this is at the time of class loading. But how much range of buffer objects got created is nothing but, here just observe, it is a buffer. It is a buffer of wrapper objects got created here. So the range is minus 128 to plus 127. Are you getting? Minus 128 to plus 127. Sir, this is minus 128, minus 127 dot plus 127. Okay, this buffer of objects will be created at the time of wrapper class loading only. Are you getting? By autoboxing, if an object is required to create, first my JVM will check is it available in the buffer or not. Assume, sir, object 10 is it available in the buffer or not? Yes. If it is available in the buffer, then by autoboxing, if an object is required to create, first JVM will check is it there in the buffer. Yes, boss. If it is there in the buffer, it will use that object. If it is not there in the buffer, then create a new object always. Are you getting? Now, is it there in the buffer or not? 10. That's why integer x is equal to 10, integer y is equal to 10 point into the same object. Are you getting? That's why in this case, in the case 3, we got is nothing but true, the answer. Same thing, is 100, is it there or not? Yes, 100, it is there. That's why x is pointing to the same, y is pointing to the same object. Are you getting? But 1000 Is it there in the buffer or not? Not there. If 1000 is not there in the buffer, create a new object always. Is it clear for all of you? Right? So this type of arrangement is there to provide support for autoboxing internally. Because of this buffering, a single object will be reused multiple times if it is there within the range. Is it clear for all of you? Right? Internally, how autoboxing concept is implemented is nothing but like. Now you may have the big doubt, sir. Why this buffer range is applicable only for this range, minus 128 to plus 127? There may be a chance to extend. Why up to this range only? Clear reason is there. That one I will explain. Are you able to understand? Okay. Add conclusion. Okay. Add internally to provide support for autoboxing. Internally to provide support for autoboxing. To provide support for autoboxing, a buffer of wrapper objects will be created. A buffer of wrapper objects will be created. At the time of wrapper class loading. At the time of wrapper class loading. Next up, by autoboxing, if an object is required to create, first JVM will check. JVM will check whether this object already present. First JVM will check whether this object already present in the buffer or not. JVM will check whether this object already present in the buffer or not. If it is already present in the buffer, then existing buffer object will be used. Next up, if it is not already available, then if it is not already available in the buffer, then JVM will create a new object. Are you getting? So first priority is always for buffered object. If it is not there in the buffer, then it's going to create a new object reusing the same object applicable only for this buffer. Are you getting? First take this code. Class integer static block minus 128 minus 127 .10 .100 followed by 127. Are you getting? 127. Okay, like xy both are pointing to the same. But 1000 is not there in the buffer. That's why new object got created, right? 1000 not there in the buffer. A new object got created. Clear for all of you, right? Okay, this. But here one small twist is there. But this buffer concept applicable only in the specified ranges. Only in the following cases. Sir, if it is the byte, buffer is available always. Because the reason is, what is the range of byte? Minus 128 to plus 127. It is the exact same range. That's why if it is the byte always, If it is a short, minus 128 to 127. If it is integer, if it is integer, minus 128 to plus 127 only. If it is a long, minus 128 to plus 127. If it is a character, 0 to 127, 0 to 127. If it is a boolean, in the case of boolean, always, because how many boolean objects are required? Only two objects, true and false. Is nothing but only two objects are required, that's why. So buffer concept is available only within this range. Except this range, always a new object will be created, right? Are you able to understand? Okay, at this point. But buffer concept is available. Buffer concept is available only in the following range. But buffer concept is available only in the following range. Only in the following ranges. Only in the following ranges. Okay, take this one. Byte always. If it is a byte always. If it is a short, minus 128 to plus 127. Integer, minus 128 to plus 127. Long, minus 128 to plus 127. Character, 0 to 127. 0 to 127. Next, boolean always. If it is a boolean, always. Character 0 to 127. Boolean always. Completed, right? Boolean case always. Okay, now here the point. Except this range. In all remaining cases, except this range, in all remaining cases, a new object will be created. In all remaining cases, a new object will be created. Except this range, in all remaining cases, a new object will be created. Is it clear for all of you, right? Okay, this same. Then you may ask, sir, why this restriction only for this range? Only for this range only it is available. Why don't you extend? Because reusing the same object always recommended, memory point of view, performance wise, right? Why only for this particular range? Why only for these particular ranges? In the remaining cases, what about remaining? Float and double. Why? In these two cases, buffer concept is not there. You may have the big doubt. What is the reason? Only for this particular range. Outside of that, why some people they didn't provide? Simple reason, observe. Suppose if you are taking one peg per day. If you are taking one peg per day, is this too healthy? Is nothing but doctor also sometimes may prescribe, no problem at all. If you are taking one bottle per day, is nothing but what will happen? One bottle per day, what will happen? Very soon is nothing but gone. It may be a chance, shortcut to go, is nothing but bottle per day. Up to certain level, we can enjoy with the advantages. Once we cross that limit, once we cross that saturation point, instead of advantage, n number of problems will come into the picture. Correct or not? Okay, this is. So now observe, up to this range, we can enjoy. But if you cross that, if you are expecting more, instead of advantage, problems will be there. How? Simple. Sir, here in our program, suppose what I want to do is, some people, can you please extend the buffer from minus 1 crore to plus 1 crore. Hey, son, can you please extend, Sun Microsystems, can you please extend the buffer from minus 1 crore to plus 1 crore? What is the problem here is, if it is the case, if the some people want to implement, then compulsory they have to take inside what? Static block. and the class integer, right? At the time of integer class loading, how many integer objects are required to create? 2 crore integer objects are required to create. But out of 2 crore, how many objects you may use? Maybe 1 or maybe 2 objects. For 1 or 2 objects usage, creating 2 crore objects at the beginning, is it advantage or disadvantage? Disadvantage, right? Just a class loading, integer class loading will take 3 hours time. Creating 2 crore objects on the memory waste, performance is going to be down. Are you getting? Just for the sake of 1 or 2 objects, whatever you are using in your program, creating 2 crore objects always is nothing but worst kind of programming practice. That's why some people what they did is most commonly used range for the programmer. Which one is the most commonly used range for the programmer? Oddly, minus 128 to plus 127. Oddly this range. But most of the time, I use the 0, or I use the 10, or I use 100, or I use 30. Up to that commonly used range only, the some people provided buffer concept. Are you getting? Commonly used range, buffer concept is there. So, if it is not in the range, no problem. It is always going to create a new object. What is the problem, right? That's why some people restricted buffer only for commonly used range. Is it clear for all of you? If I can extend minus 1 crore to plus 1 crore, what is the problem now? You will come to know, right? That's why one thing. Second thing, sir, why? Float and double case. Why the some people they didn't provide buffer concept? Simple, Anna. In the case of float and double, between 0 to 1, how many double values are there? Between 0 to 1, how many double values are there? How many are there? Infinite number of values. Then if I start implementing buffer between 0 and 1, is it possible to implement buffer between 0 to 1? Not. It is impossible to provide buffer because between 0 and 1, infinite number of double values are there. 0.1, 0.11, 0.001, 0.121, like infinite number of values are there between 0 and 1. How I can restrict the buffer concept? That's why float and double we can't restrict for particular range because 0 to 1 only infinite number. How I can implement? That's why buffer concept is not there in the case of float and double. Are you able to understand it? So this buffer is available here. So internally Autoboxing buffer concept is associated, right? Any explanation is required, Anna? Based on this, let me go for some more examples. Have you call these things, right? Okay. Now let me go for some more examples here based on this buffer. Here I am taking. See this one. Now you people can get much clarity. Integer x is equal to 127. Integer x is equal to 127. Integer y is equal to 127. 127. System.out.println x double equal to y. Is it true or false? True. Not required to keep any explanation. Is it going to use from the buffer or not? Yes. That's why what the answer? True itself is the answer, right? Next I am taking here, see, integer x is equal to 128, integer y is equal to 128. Sir, 128, system.out.println x double equal to y. What the answer? False. Not required to keep any explanation because you people aware what is the internal reason for that. Are you getting? False itself is the answer. Okay. Now here see, here boolean x is equal to false. Boolean x is equal to false. Sir, boolean, how many boolean objects are required? Only 2. That's why can I maintain buffer or not? Yes. In the case of boolean, always buffer is available. No problem at all. Boolean y is equal to false. Boolean y is equal to false. SOP of x double equal to y. What is the answer? Because both are pointing to the same object, right? True is the answer. Next, double d is equal to 10.0. Double x is equal to 10.0. Double y is equal to 10.0. Double d is equal, double x is equal to 10.0. Double y is equal to 10.0. System.out.println x double equal to y. What is the answer, Anna? 10.0, 10.0 is nothing but what? False itself is the answer. Any explanation is required, okay? Now you can able to understand. Integer x is equal to 10, 10, true. 100, 100, true. 1000, 1000, false. What is the reason for that? Now take these 4 examples. Take clearly. Integer x is equal to 127. Integer y is equal to 127. SOP of x double equal to y. So to provide support for autoboxing, internally a buffer of wrapper objects got created. Buffer of wrapper objects got created. Integer x is equal to 127. Integer y is equal to 127. SOP of x double equal to y itself is the true. Next, integer x is equal to 128. Y is equal to 128. X double equal to y, false. True, false. Next one, true. And then false. True, false, like. So, any explanation is required. So, in the discussion forums, you know, the people are going to fight like anything to understand these concepts. Up to 127 true. Suddenly 128 is nothing but false. What is the internal reason for that? Now you got clearly. Completed, right? Now, there is one more point I have to explain. Just based on same concept is the same. Let me clarify one more. Okay, this is. So, do you know, internally, autoboxing concept is implemented by using which method? Why you are thinking? Internally, autoboxing concept is implemented by using value of method. Have you remembered? Auto unboxing is implemented by using XXX value. Internally, autoboxing is implemented by using value of method. Sir, buffer concept is available for autoboxing. Autoboxing internally implemented by using value of method. Buffer concept is available for value of method or not? Yes. Okay, because internally autoboxing is implemented by using which method? Value of only. That's why buffer concept is applicable for value of methods also. Is it clear, right? Okay, this is. So that's why in the case of value of method also, it is always going to consider from buffer only. A new object won't be created if it is there in the buffer. Constructor value of, which one is recommended to use? Value of method. Internally performance improvements are there. Have you observed sometime before I told value of method is recommended because it will work internally a bit intelligent way, right? Okay, first add internally autoboxing concept is implemented. Internally autoboxing concept is implemented. Internally autoboxing concept is implemented by using autoboxing concept is implemented by using value of methods. Internally autoboxing concept is implemented by using value of methods. Value of method. Hence buffering concept is applicable. Hence buffering concept is applicable. Buffer concept is applicable. Buffer concept is applicable for value of methods also. Buffer concept is applicable for value of methods also. Buffer concept is applicable for value of methods also. Okay, like here now observe this one. Sir, I am taking integer x is equal to new integer of 10. Integer x is equal to integer of 10. Integer y is equal to new integer of 10. Integer x is equal to integer of 10. Integer y is equal to integer of 10. SOP of x double equal to y. Okay, like first one. Second, integer x is equal to, sorry, integer x is equal to, here I am taking 10, integer y is equal to 10, SOP of x double equal to y. Okay, like now integer x is equal to, integer x is equal to integer dot value of 10, integer x is equal to integer dot value of 10, integer y is equal to integer dot value of 10, integer dot value of 10, SOP of x double equal to y, SOP of x double equal to y. Next, integer x is equal to 10, integer y is equal to integer dot value of 10, SOP of x double equal to y. Can you tell first case what the answer? Sir, new operator, compulsory new object will be created. Buffer concept is not there for constructor. That's why what the answer? False. Second one, Autoboxing, not required to keep explanation. True itself is the answer. Third one, true or false? Integer dot value of 10, integer dot value of 10. Sir, internally these two lines after compilation will become like this only. So that's why, so here true, automatically it also true. Boxing buffer concept is available for value of method. That's why what the answer? True itself is the answer. Next up, integer x is equal to 10, integer y is equal to integer dot value of 10. What the answer? SOP of x double equal to y. True, because this one internally converted into this style only. Is buffer concept is applicable for value of also, right? Okay, take all. So false, true, true, true is the answer. Take all these possibilities, right? That's all. How internally this concept is implemented